All right, for lesson 2, we're going to talk about Earth's spreading ocean floor. You should be able to relate ocean floor spreading to continental drift and how that links. You should be able to describe what causes a mid-ocean ridge and how do magnetic reversals provide evidence for ocean floor spreading. Now, you might hear me say seafloor spreading, ocean floor spreading. It can be referred to as either or. Both terms are interchangeable. Okay, so we talked about Alfred Wegener with the last lesson. Well, nobody believed him. Harry Hess is the one that brought about the evidence that then allowed people to start believing what Wegener was trying to say. So Harry Hess studied the ocean floor and discovered mid-ocean ridges. A mid-ocean ridge is an underwater mountain that has a deep crack running through the center, and it's formed from underwater volcanoes. So basically, it's a crack in the earth that allows the magma to come up, cool underwater, and then as it spreads, it creates a mountain. This makes the single largest mountain chain in the world, and this can also be called seafloor spreading. So that's where I have they're the same term basically. Okay, so seafloor spreading or ocean floor spreading, whichever we want to explain it, is when the ocean floor moves away on both sides of the mountain range. So here would be underwater. Here is where our two ocean floor plates are going to move apart. And as it moves apart, heat rises, so our magma is going to rise, and it's going to end up cooling. And as it continues to pull apart, that is going to rise even higher and higher because of the fact that it's building upon itself. Seafloor spreading helps explain how continents drift, and as the ocean floor moves, it takes its continents with it. So that's part of the whole Wegener saying that continents can move, and they had to have once been a large landmass. Now, individual mid-ocean ridges are perfectly straight, but the ridge as a whole curves due to transform faults. So here we have like the mid-ocean ridge is straight, but because we have some of these transform faults in it, it can end up causing a shift in where that mid-ocean ridge is. Transform faults are breaks in the crust along which movement occurs. That isn't the best description of that, but here's a transform fault where we got this one is moving this way, transform fault where one is moving one way and the other's moving the opposite way. So that would be the transform. Okay, mid-ocean ridge rock layers. Rock samples from the mid-ocean ridge indicate that the rocks next to the mid-ocean ridge, so here, are younger than the rocks further away. The youngest rocks are in the center, where the magma is coming up and being formed into the rock, cooling into the underwater mountain. And as the ridge spreads, so as these plates move apart, the rock moves too, so then the older rock is further away. Now, one way they can discuss this is they have studied the magnetic stripes in ocean floor rocks. So what happens is there's magnetic pieces of minerals that are in the rock that forms, and when the magnetic rock cools, it cools such that it's pointing to either the north or south pole. Okay, so the magnetic minerals identify the direction of Earth's magnetic pole during the time the rock layers hardened. And we know that Earth's magnetic pole reverses from time to time. The pattern was the same on both sides of the mid-ocean ridge. So the stuff in the center is cooling at the same time, so they're going to have the same orientation for our north-south for the magnetic idea. That next layer on both sides, that yellow one, those would be the same because those would have formed when it was in a reversal, and so on and so forth. Now, we'll talk a little bit more about that reversal. I've got a couple videos that you'll watch that will help you understand a little more. But the reversals, they can be dangerous to, from what we understand, they can be dangerous when the magnetic poles switch. Earth's size stays the same. The mid-ocean ridge causes the ocean floor to get larger. However, the Earth does not get bigger. And the reason is because we have the creation of crust along the mid-ocean ridge, but that gets balanced out by the destruction. So over here, this ocean floor is going to dip under, and this part is going to end up getting destroyed. So it's building here, destroying here. And these are subduction zones. We'll talk more about those. Okay, subduction zones are locations where the older ocean floor moves deep into the earth along trenches and forms volcanoes. Okay, so here's our subduction zone. We get a trench near the land, which is going to be a deeper area. It's a V-shaped valley that lies along the bottom of the ocean, but it's going to be deeper. So like when the continent ends, it's going to kind of have a drop off. Now the trenches are found close to the continents. The rock can push deep and get melted. So this crust that's going under is going to end up getting melted. The melted rocks can then end up causing volcanoes to form. We'll talk more about that when we do our drawings for this unit. And the trenches are the deepest parts of the ocean, and an example would be near the Alaska's Aleutian Islands. And this will come up again later towards the end of the unit.